Station, this is Houston. Are you ready for the event?
Station's ready.
The Courier, this is Mission Control Houston. Please call station for a voice check.
Station, this is Amy Rivers with the Courier. How do you hear me?
And Amy, I've got you loud and clear.
Great. Thanks for speaking with me this morning, Raja. I don't know if you were aware, but the mayor of Cedar Falls organized a watch party to witness you commanding the shuttle into space November 10th, which they found very awe-inspiring. So I'm sure they'd want to know, what was that like for you blasting off from Earth and traveling to the station?
Well, yeah, I know Mayor Green had emailed me that they were setting up something, so I appreciate the folks of Cedar Falls and Waterloo coming out to watch. Honestly, it was a lot like the simulator, which I think is a great testament to the training teams at NASA and Johnson Space Center, as well as SpaceX in our case for the Crew Dragon. But it really felt like we were sitting in what we call the Buck, which is the mock-up at SpaceX in Hawthorne, other than the fact that there was a whole lot more noise and the feeling of accelerating. It kind of felt like going up in an elevator. If you've ever gone to like a skyscraper and those elevators that go up really fast, that's sort of what it felt like early on. And then once the first stage cut off and the second stage lit, you get the feeling sort of like you're in a car, like decelerating really fast where the seatbelts lock out, and then accelerating really fast when the second stage lights. And then, of course, once the second stage went out and we were weightless, that was a pretty amazing feeling. It felt kind of like being in a roller coaster initially, like when your stomach drops, but it keeps feeling that way, and then it takes a little while to adjust. But it was pretty amazing experience. We were all cheering and giving each other high fives once the second engines cut off, the second stage cut off.
What's living on the space station like? What's a typical day for you?
So that's one of the coolest part of the jobs, is every day it's completely different. There's kind of, in my mind, three sort of big things going on. One is research, obviously, and within that there's two things. There's human research, so where we're the subjects, and then there's what I call like basic science, fundamental research. And so in that case, we're the eyes, the ears, the hands, really, for scientists on the ground that are doing experiments. So that's the two biggest things. And then the other part is housekeeping and maintenance. And so the station's been manned, or people now for 20 years and continuing now through 2030 with the current budget plan. And so just like a 20 to 30-year-old house, there's plenty of tasks that have to be done to keep the lights on, keep the water running, keep the air workable in our case. And so I'd say a good chunk of our job, too, is all the maintenance and housekeeping that goes with that. And so on any typical day, they plan our weeks based on the priorities. But every week and every day is slightly different depending on what's going on. So the last about month, the Cargo Dragon has been here with a bunch of science. And Cargo Dragon is unique, and it's the one vehicle that goes back and lands. And so any science that takes the ground to analyze it, we try to pack into that time while it's here. So we've got another day before that goes back, but there's been a whole lot of science this last 3 weeks.
And before we get into the science, I wanted to just ask one more sort of housekeeping question. What's it like looking down on Earth for more than 200 miles up? Are there any interesting landmarks or weather patterns you've spotted?
Yeah, so I think the thing that's most striking is there's a whole lot of water, which I guess you academically, I knew that, more than 2/3 of the Earth is water, but when you see it out the window, and just about every time you go and look out the window, it's water. And then when there is land, it goes by pretty quickly compared to how long it takes to get over the oceans. And then the next most striking thing is it's really hard to figure out where you're at without cheating and using a map. And I think it's just a testament to the fact that there's really no borders or lines other than the ones we create. And so when you look at it, the Earth from space, it's just one homogeneous mass of different land masses and water. And it's pretty cool and enlightening, I think, to think of it that way, and also realizing the fragility of it. And I think that's the other striking thing. We see 16 sunrises and sunsets a day, and as the sun either rises or sets, it highlights, and basically what it does is illuminate just the sliver of atmosphere. And when you realize how thin that sliver is, you can actually see the upper edges of it as you look kind of edge on to the Earth. And it's, compared to the Earth, it's like the shell of an egg. It's so thin, and just realizing that's everything that we know and love and understand is in that one little thin shell. Just really striking how important it is to preserve that.
Sure. Of course, you're not up there to hang out and sightsee. You, as you noticed, are working on some pretty crucial research. I wanted to ask you first about the long-duration spaceflight experiments that you had mentioned when we talked previously. What have those entailed, and what are you finding out so far in the course of that research?
Yeah, so what we know about long-duration spaceflight is there's a lot of things that change in your body, both at the macro level and even at a microscopic level. And so Mark Vandehei, who's up here with me, he's on track to be up here for over 300, basically a year. And we've got Christina Cook, who was up here essentially a year, Scott Kelly. So we're building that data set of people who are here longer term to understand what happens as we go beyond 6 months, 7 months, and on to years, which we'd have to understand to go to Mars. So some of the things we already know that we are confident about is it has a lot of the similar effects like aging, like the equivalent of aging. And so whether that's your arteries hardening, whether it's bone loss, some eyesight changes, things like that, most of those go back to normal when you land. And there's also some DNA changes. So when Scott Kelly was up here, they had the benefit of doing a genetic study between him and his brother and saw actually DNA changes while he was in orbit. And those were actually opposite those macro changes. So it was actually getting rid of some or changing the DNA in a way that actually or shortened, I guess, or had the reverse effect of aging. But when he came back, it reverted back to normal. So those are definitely things we're trying to understand more about. Some of the studies we're doing on our current mission are having to do a lot with the gut biome and trying to understand that with different foods, different diets, and then taking a look at how that is a predictor of some of these other things, which also has implications for Earth researchers. We look at how the biome in your gut can be an indicator for all kinds of other diseases or conditions.
And you had also previously mentioned combustion research, materials research. How many research projects are you undertaking while you're up there, and what's been some of the more memorable ones for you, or ones that you think might have the most interesting implications for life on Earth?
So, Amy, it's hard to listen. There's over 300 in the time we're up here, which is pretty amazing and also hard to keep track of. It's more than one a day going on. I think, and to your question, so the combustion thing, actually, just the other day, I was swapping out what's called the ACME experiment. There's an igniter and a very tiny sphere of an alloy that gets superheated. And so some of the things we're investigating with some of that combustion research is cold. We call it cold flames. And some of the benefit there is if we can find flames or combustion processes that have lower carbon emissions. And so, obviously car engines, any kind of power generation that involves carbon fuels gives off carbon emissions. And so if we can find ways to combust that at a cooler temperature and do it controllably, that would be game-changing for carbon emissions on the Earth. The other thing that we were working on as part of the space, what SpaceX brought up, and that Cargo Dragon, was some genetic research on plants, and specifically some cotton plants. So cotton's really hard to genetically modify on the Earth, and so here we can do it a little faster and kind of come up with maybe some ideas as to making basically cotton more drought resistant. And so cotton's a pretty big product on the Earth, used in everything from clothes to manufacturing. And so if we can figure out ways to make that require less water, that would have big implications for farming across the world.
Mm-hmm. While you're up there, how often have you been able to call or send and receive messages with your family and friends? And what's that process like? Is it just like a regular phone call or sending an email? Is there a delay?
So it's pretty similar, especially with my immediate family. So I'm able to talk to them about once a week via video call. It's a lot kind of like a Skype or a FaceTime type format, and feels very much like that. The only difference is there's a little bit of a lag. So we were trying to, if we're trying to do real-time interaction, you have to wait a few seconds, and then that bandwidth that's required to do a video requires certain satellites. And so every few minutes there'll be like a handover when we change from one satellite to another, and so there'll be a break in the communication then. But the ground control team does a great job trying to find the biggest blocks of chunks of time so that we have a chance to talk to our families and catch up on things. And then for phones, it's essentially an internet phone, and so we can dial down. People can't call us, but we can call them. And again, though, it's dependent on the satellite tracking times and coverage times. So when we have a satellite that can basically point at us and point at the ground and relay that information, then we can use the internet phone and call down. But and then email, we are able to email, and we get those pretty regularly. We do actually still have keep track of what's going on the ground with our jobs and stuff there, and so they come through pretty quickly. There's just a size limit on attachments, but we're able to keep up with all the stuff going on in our office back home.
For better or for worse, I suppose. And when is your expected arrival home? And once you're back, how long until you find out if you're picked to go on the Artemis mission to the moon?
So right now we're slated to come back at the end of April. It really is dependent on Crew 4, which is the mission that replaces us. So that will be the next SpaceX Crew Dragon that comes up here to man the International Space Station. And what we'll have to do is what's called a direct handover, meaning they'll have to show up, and then once they show up, we'll take the time to kind of show them the ropes up here, and then we'll come back. And so right now that's slated for the end of April. And then as for Artemis, right now the goal is still by 2024 to be beyond, trying to put humans back on the moon to stay this time. And so there's a large group of us in the astronaut office all working different projects on the Artemis development. So there's the SLS, which is the rocket part, the heavy lift to get us out of low Earth orbit and into lunar and eventually Martian orbits. There's the Gateway, which is kind of the lunar space station, which is the place where we would go to and then use that as a base to go to the surface and then potentially on to Mars. And then there's the Orion capsule, which is the way to get from the rocket to the Gateway, and then finally the landing system, which is the way to get actually to the surface of the moon. So 4 big projects all going on simultaneously, so plenty of work and development going on, and lots of work, and everyone's really charging ahead. And so, yeah, when I get back, I will probably get involved, I imagine, with some of the development. There's a lot of testing going on, so everyone in our office has been helping out with that. And yeah, it remains to be seen how we figure out who winds up going on those missions. But with the plan of Artemis to go to the moon to stay, I think there's going to be lots of opportunities for decades to come, not just for me, but for all the kids in high school and college. We're going to the moon to stay, and Mars and beyond. And so there's definitely room for a lot of people to help out and be part of that.
And speaking of those kids that are watching you in this mission closely, what would you say were some interesting or weird things that have been going on that you weren't aware of before you actually got to space?
I think for me, it was weird, but also pretty amazing how quickly your brain adjusts to this. And so, for about the first 2 or 3 days, I mean, you kind of feel a little stuffed up. It's like I mentioned, when the second stage first cuts off, you feel like you're falling, and that sensation doesn't go away for a while, and eventually your brain has to make that the new reality. It's the one thing we really can't train for on the ground, so we can do just about everything else except actually work in near zero G. And so actually experiencing that and adapting to it, to me, has been the most surprising thing and the most amazing thing, because after about 2 weeks, your brain just sort of figures it all out. So early on, when I would come out of our crew quarters, there's kind of one back behind me here. So this is one where Matthias, my European crewmate, lives in. So we actually live, when we sleep, we're inside these. And for about the first week or so, when I would come out, I'd always have to orient myself right side up and try to figure out where everything's at. But over time, it became a lot easier just to work on the walls, on the ceilings. And now as we go between modules, there's really no sense of a right way to be up or down. You pretty much adapt as normal. And honestly, really the only time we do think about it is when we're talking to people on the camera, because it's really disorienting for people usually on video. If we're talking to them or flipping upside down, talking back to them, it's hard for them to track us. But other than that, it doesn't really matter which way is up, and it's pretty amazing how fast your brain can just learn from that. That's actually some of the research we're doing too, is some sensory perception research where we wear different things that eliminate either our sight or our hearing, and then try to look at how the brain adapts to that, which has implications on the Earth for people who've been in injuries or have disabilities and have different neural pathways depending on the senses they have.
And finally, any message that you want to send to the Cedar Valley now that you've been up there for a couple months?
Yeah, I love looking down in Smotin, Iowa. I've gotten better at it. My big landmark is to find Lake Michigan and then work my way west from Chicago, and I can always find the bump out around the Quad Cities and Dubuque area, and then work my way along I-35 and I-80 and kind of find all the major cities. So it's always comforting to be able to look down and spot my hometown, spot where I grew up. And yeah, I think my message would be, thanks to the teachers, the community, everyone that got me and my family here. My wife, as you probably know, is from Cedar Falls as well. And so I think both of us consider ourselves homegrown in Iowa and the Cedar Valley, and really the reason I'm here and the reason she's as successful as she has been is thanks to the support and love we've gotten in Cedar Valley as kids and even as adults now. And so, yeah, thank you very much to all of you who helped enable us to be able to do this research and great work up here on the space station for you.
That's all the questions that I have. I really appreciate you talking to me today, Raja.
Yeah, no problem, Amy. Thanks for taking the time to do it, and appreciate it.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants from the Courier. Station, we are now resuming operational audio communications.